Hello everyone, my name is Ljubojević. I'm a PhD student and digital assistant at the Faculty of Mechanical Engineering.
Sorry, Pablo, you should be a little bit louder.
Okay,
And
okay.
you guys, can you tell us, do you hear us? Do you hear us?
Need to be loud.
Yes, yes, okay, thank you.
I'm Pablo Ljubojević. I'm PhD student and digital assistant at Faculty of Mechanical Engineering here in Belgrade, at the Department of Machine Design. First of all, it's my pleasure that I'm a participant of this conference, and today I'm here to present a paper written by two co-authors, full Professor Tatjana Lazović, teaching assistant Ivan Simonović, and me. The name of the paper is Safety Factor of the Bolted Flange Joint. Flanges can have different functions. In our case, we analyze flanges which are loaded in torque. The main function of this flange is to connect two shafts and transmit rotational torque from one shaft to another. They are commonly used in the industrial machinery, pumps, and other equipment where this power of transmission is required. And they can have various types of designs. They can have different sizes, can be built from different type of materials. All of that depends on their function. Here on first picture, we can see how that type of flange looks like, and you can see two parts of flange which are connected with using bolts, group of bolts. Most of machine systems are composed of the large numbers of components. By joining that components, we ensure integrity, structural integrity of machine system. Also, we achieve a desired position of all members of joint, and we can create one functional unit. The special advantage of using bolted joints is disassembling and or reassembling, easy maintenance and remanufacturing, and protection. And protection from particles of pollution, from moisture, from liquids, also reduction of vibrations and noise, etc. There is no exact evidence, but it is assumed that the first bolted joints existed 500 years ago, and through history they experienced intelligent development in the field of construction, also increasing load carrying capacity and reliability through a process of standardization. In paper by same group of authors, we analyzed the safety factor ratio under the same geometric and operational conditions. And the main function of this type of bolted joints is to avoid slip between members of the joint. We have fitted and planted bolted joints. Fitted bolted joints behaves like a pin, and in their case we have two safety factors: safety factor of contact pressure and safety factor of shear. When its length B is equal near 0.5 value of D2, these safety factors are equal, where D2 is diameter of untreated part of bolt's body, or shorter, that is diameter of bolt shank. In the case of clamped bolted joints, the relative movement of parts are predicted. We have one friction force, and that friction force depends of tightening torque, or we can say clamping force. And we can also see on that slide the F/H ratio. That ratio can be expressed with this equation, and it depends on factor C. The factor C is a clamping factor, and the factor C depends on clamping parameters. A range of factor C is from 6 to 36, and also it depends of nominal thread diameter or bolt size. Here in this equation, D3 is the minor diameter of clamped bolts. And finally, on this diagrams, on the first diagram, we can see the minor thread diameter and bolt shank diameter depending on bolt size. Their values increase with increasing bolt size as a linear function. We can also notice that the bolt size impact have greater impact of increasing of diameter D2. On the second diagram, we can see that the ratio of these two diameters decreases with increasing bolt size. And finally, on third diagram, we have extreme values of FOS ratio depending of bolt size. Extreme values because we calculated them when factor of clamping C is equal to 6 and equal to 36. After that, we ask ourselves question: what if we change the number of bolts? And when we change number of bolts, we can also change the pitch diameter, because why there is no good reason why we should put 3 bolts on the same pitch diameter as 12. We can see that comparison on figure number 4. Number of bolts range in our case was from 3 to 12, and this Cn is a factor of number of bolts, and the range of this factor is from 0.25 to 1. Using simple math from the figure 5, where is geometrical parameters of grooved bolted joints, we can express length of Rx as a function of D and of pitch diameter Ns, where S is the width across flats. Also, we can express the distance between bolts using length X and using parameter E. For practical, structural, and technological reasons, factor E cannot have small values because in that case, the distance between bolts and the pitch diameter would be small, and we cannot construct that type of coupling. The analysis of rigid couplings with number of bolts from 3 to 12 up to size M24 show that the minimum value of factor E is 3. Now we can express pitch diameter as a function of number of bolts and parameter E. Also, we can express FOS ratio in the form that we can see here on the slide, where this ratio of sinus functions can be changed with parameter K, and that parameter K increases by increasing the parameter E, so it can be replaced, but its limiting value, which is mathematically provable, equal to factor of number of bolts that express you can see on the slide. And finally, we get simpler form of factor of safety ratio. We can see that that ratio here depends on parameters of clamping, number of bolts and bolt size. Here on diagram on figure 6, we have minimum FOS ratio depending on bolt size and number of bolts. Why I say minimum? Because that was calculated for clamping constant minimum value. In order to be quick, I will just read that some of the main conclusions from this diagram. The FOS ratio decreases with an increase in the bolt size. The influence of the number of bolts decreases with an increase in the bolt size. Combination of small bolts in all approximately equal in an approximately equal number of bolts give the highest value of this ratio. Here we can 3D version of previous diagram, and also we can conclude that the load carrying capacity of fitted and clamped bolted joints decreases in the combination of large joints with large differences in number. The minimum ratio or factor safety is not higher than 1 in cases when it's factor of number of bolts equal 0.25 and 0.33, and by varying the number of bolts and bolt size, difference of load carrying capacity of fitted and clamped bolted joints can be reduced. We can also express the factor of number of bolts for the case when its load carrying capacity is equal to our fitted and clamped bolted joints. And here on figure 8, we can see possible combinations of size and number of bolts for FOS ratio equal to 1. We can see that for clamping constant, when its clamping constant is equal to 36, there is no possible combination. So we have to go with lower values of this constant. Also, we can express that constant as a function of number of bolts and bolt size. And here in table 1, we can see that values depends on bolt size, depends of number of bolts. So constructors can have these values if they want to achieve equal load carrying capacity. And here is just example of fitted clamped group bolted joints with the same bolt size, with the same FOS ratio, and with the same value of parameter E. It is interesting that that small flange with fitted bolts have the same load carrying capacity as that big flange with clamped bolts. And we can also see that pitch diameter also depends of diameter of shaft. So they have to be considered in calculation. And for the end conclusions, all the conclusions I already said during the presentation. For the end, I just want to say that the aim of this paper was to provide practical results that can be used by constructors to make an appropriate choice of bolted joint type by combining various parameters, geometric and operation.
Okay.
Thank you for your attention.
Okay. I think that my young colleague had a really interesting presentation and research. So congratulations, Paula.
Thank you.
Thank you. Is there